Today's lesson is 8.2, Perimeter and Area of Trapezoids, Rhombi, and Kites. Let's go ahead and start with the trapezoid. The area of a trapezoid is 1/2 the product of the height and the sum of its bases. In the formula, you will see these three variables. B1 stands for base 1, B2 stands for base 2. Now remember in our trapezoid that the bases are going to be the two parallel sides, the only two parallel sides in our trapezoid. The other variable you will see is h, and this is the height. Now remember most times that your height is a diagonal line in the center of your trapezoid. It must go from base 1 to base 2, and it is going to be perpendicular to one of the bases. Okay, so we can think of it as the definition said, 1/2 times the height times the sum of the bases. That's this one right here. You can also, because of the fraction 1/2, think of it as the height times the sum of the bases divided by 2. That's the one I like to use because I know we don't like to use fractions very much. Let's go ahead and do example 1. Find the area of the trapezoid. We're going to start by labeling. We're going to start by labeling our base 1 and base 2, and then our height. So I'm going to come in here and say this line here has to be base 1, and then this side here will be base 2. Now I can interchange them, that's perfectly fine, but one of them is base 1 and one of them is base 2 because these are the two parallel sides of my trapezoid. Now the height must be perpendicular, so this must be the height. I could also find that height right here by putting a dotted line and making my 90 degrees here as well. This is also my height, and these two heights would be equal because I'm creating a rectangle there with my blue and my reddy orange colored line. All right, so since those are congruent, so is the top to this part in the bottom. So this is also 6, which means I know that this little part right here has to be 3 centimeters. Now what this is going to do is it's going to help me find my height. It's going to allow me to find this one, which is also the one that I have marked with H, because these are actually the same. I could go ahead and add H here for you. What I'm noticing is that I have a right triangle right here. And what I'm going to do is I'm going to take that triangle and I'm going to draw it over here. Oops, that is not a triangle. Let's try a little bit better, shall we? Here we go. There's our right triangle that we see. And I can even add the 90 degrees down in the corner. There we go. Now, what I notice is that there's a 30-degree mark here. If there's a 30-degree angle mark in this corner, then that means this corner has to be 60. Because I remember in a prior lesson us talking about a 30, 60, 90 special right triangle. So that's what I'm going to use to help me find H over here. I'm going to make it nice and thick. There we go. I'm going to use that to help me find H. Let me go ahead and change my color just really quick. And I've got to remember when I do my special right triangle, my 30, 60, 90, there's a ratio between the sides. The side with the 60 and the 90 is my short side, and we call it A. The side with my 30 and my 60 is the long side, and we call it A times the square root of 3. I'll put the little times in there. And the hypotenuse, which has the 60 and the 30 on it, is 2A. Now I remember being told to circle this and set these two equal. This is going to allow me to find A. Once I have found the value of A, that A is the same as my H, as my height. So I'm going to go ahead and I'm going to solve this by saying A times, there we go, times the square root of 3 equals 3. Well, if I want to get the letter A by itself, and I'm going to change it to blue because that A is the blue H, so that's not going to bother me. I'm going to go ahead and divide by the square root of 3 because whenever I'm multiplying, that's how I get rid of multiplication, right? All right, we don't like the square roots on the bottom, so we're going to multiply by the square root of 3 over the square root of 3. This is called rationalizing the denominator. Now this a, which is the same as this a right here, is going to equal 3 times the square root of 3 over. Now, since the bottom both are the square root of 3, I can multiply 3 times 3, which is the square root of 9. Well, I know the square root of 9, miss. The square root of 9 is 3. And I know that 3 divided by 3 is 1, so they'll cancel out, and so I get the square root of 3. My height then equals the square root of 3. Now I have everything I need to go ahead and do my area. My area equals my height times base 1 plus base 2 divided by 2. What I'm going to do is I'm going to go ahead and add together on the top, and then I'm going to see if I can divide by 2. So 6 plus 9 is 15. That 15 is going to come in front of my square root of 3, because remember, we normally like to see it as 15x instead of x 15, right? Does that make sense? We want to see it this way. We don't like to see it this way, even though they are exactly the same. 15, can I divide it by 2? I can, but I'm going to get a decimal. So guess what? This is my answer. I'm going to pick my units of centimeters squared. All right. Example number 2 for the trapezoid says, find the height of a trapezoid with bases 6 centimeters and 12 centimeters if its area is 45 centimeters squared. So what I'm going to do is they want me to find the height, and then they told me that the bases are 6 and 12 centimeters, and then they told me that the area is 45. So I'm going to use my area formula, and I'm just simply going to write down the formula. And then I'm going to plug into my formula everything I know. So I'm going to go ahead and color code it. There we go. And now I can go ahead and start plugging it in. Notice that right here they say that the area is 45. Well, the area is the capital A, so that's where the 45 is going to go. They're asking me to find the height, so this is going to be my variable. And inside, they told me that the bases are 6 and 12 centimeters. So I'm going to go ahead and say 6 plus 12. And of course, I'm going to divide by 2. Now, what I have to do is I have to solve for h. H is the only variable in this equation. It is the only letter, right? So I'm going to go ahead and multiply by 2 because we don't like a fraction. 45 times 2 is 90. I can go ahead and add inside my parentheses. 6 plus 12 is 18. And remember, there's a multiplication. Parentheses always means that there's a multiplication. So all I have to do to find h is divide by 18. And 90 divided by 18 is 5. Now the height would not be centimeters squared. The height would simply be centimeters if I were to pick a unit. All right, let's go ahead and move on to our rhombus. The area of a rhombus is 1/2 the product of the diagonals. Notice in our formulas, there are 2 of them. So you see the one that's written there, 1/2 times D1 times D2, or we can think of it as D1 times D2 divided by 2. That's the one I personally like. And just remember that your diagonals are going to be your D1 and your D2. Okay, those are going to be your diagonals. The diagonals must go across the across the rhombus from vertex to opposite vertex. So in example 3 here, let's go ahead and we're going to find the area. I'm going to use my colors here to help me. There's one diagonal, and there's the other diagonal. Now I can already see that D1 equals 4 plus 4, or 8 units. D2, however, I've got to remember some properties about my rhombus to help me to find them. Now, just like in D1, where the two pieces of the diagonal are equal, this also happens in D2. So these two pieces are equal as well as the 4 and the 4 were in the blue one. The other thing I have to remember about the diagonals in my rhombus is that they do create a 90 degrees. They are perpendicular to each other. This is very helpful because now I have created myself a right triangle. So we already saw with the trapezoid that you can use your special right triangle 30, 60, 90 to help you find a missing side. But for this one, there are no angles. Take a look, there's no angles in the corners, but I do know two of the sides of my 90-degree triangle. So I can go ahead and do the Pythagorean theorem. I'm going to go ahead and say a squared plus b squared equals c squared. And I'm going to look at my triangle. Remember, here it is. This is the one that we're focusing on. And I need to find C. Remember, C is always the one that does not have the 90 degrees, so the 5 is going to be my C. Here's my C, and I'm going to call this one A, and I'm going to call the one that I need to find B. So I'm going to say 4 squared plus B squared equals 5 squared. 4 times 4 is 16. 5 times 5 is 25. Don't forget to look at your equal sign. Where are your numbers? They're on opposite sides, so we're going to subtract. We're going to subtract 16 from 25, which gives us 9. B squared equals 9. And then remember, the last step of the Pythagorean theorem is to always take the square root. So B is 3. So this is 3, which means this is 3. So if I come in to find D2, it's 3 plus 3, or 6. And now I can go ahead and I can use the formula. I'm going to use this one right here to do D1 times D2. Go ahead and do this up here. D1 times D2 divided by 2. All right, so area equals D1 times D2 divided by 2. And I can go ahead and put that all in the calculator at the same time, and I end up with 24 units squared. All right, our last shape for today is the kite. And the area of a kite is equal to 1/2 the product of the lengths of the diagonals. So the same formula for my kite, I'm going to have D1, right? D1. I'm also going to come over here and do this. There we go. And D2. These are my two diagonals. Now, just like in the rhombus, these ones, they don't necessarily bisect each other. The shorter one does. This part is equal to this part, but in the longer one, they do not bisect. So you can't say that this part and this part are equal. In fact, you can tell that they're not. But they do create a 90 degrees. They are perpendicular, so we can go ahead and do that, which means we could, in fact, be using our Pythagorean theorem or our special right triangle, 30, 60, 90, or 45, 45, 90. So let's go ahead and take a look at our last example. Find the area of the kite. I'm going to start by labeling my diagonals. So here we go. There's one diagonal, and there's two diagonals. Now the shorter diagonal, which is the blue one, is going to be this piece equal to this piece. This is always true. And then remember, they are perpendicular, so we are creating a 90-degree right here. And of course, it does go all the way around. Remember, if you look back at your notes, it does go all the way around, right? The reason I'm focusing here is because they gave me the side of this right triangle. And by getting the side of this right triangle, I can find the missing piece of diagonal 2, and I can find half of diagonal 1, which will give me the other half as well. Now, I'm going to focus on this right triangle right here. So let's go ahead and pull it out, and let's take a look at it. Now, the cool thing about this right triangle is that it is a special right triangle. This right triangle is a 45, 45, 90. Notice how they told you this angle is 45? Well, guess what? The properties of a kite say this one is 45 because this angle and this angle are equal. And so that line, that blue diagonal is is bisecting it. So this is 45 degrees, which means this is 45 degrees, and I have a 45, 45, 90 triangle. I'm going to go back and I'm going to label it. I know that the two legs are both A, and I know that the hypotenuse is A times the square root of 2. These two are equal, and I'm going to solve that equation. I'm going to put the A times the square root of 2 first. There we go. Remember, it is being multiplied, and I'm going to put the A in blue because this is going to give me the blue piece that I need, but it's also going to give me here the orange piece that I need because this is the orange leg and this is the blue leg, right? You can see it in the kite. All right, so I'm going to go ahead and divide. Oh, why do I have the square root of 12? I should just say 2. There we go. Let's divide by the square root of 2 and then it disappears. If I divide by the square root over 2, I notice on this side I have it on the top and bottom again, so it will cancel, and that A is equal to 16. So what that means is the blue A and the orange A are both equal to 16. So this is 16, this is 16. This is 16, this is 16, this is 16. All right, let's go ahead and find our diagonals. Diagonal, oh wait, let's do the blue one first because that's diagonal 1. 16 plus 16, 32. And diagonal 2 is going to be 40 plus the 16 that we just found, and that's going to be 56. Now I can go ahead and I can put this in my area formula, which is D1, 32, times D2, 56, divided, let's try that again, divided by 2. All right, let me just come in here. That's just a 32. There we go. No, that's still pretty messy. Perfect. There we go. 32 times 56 divided by 2. I put that into my calculator and I get 896 units squared.